Alright, so moving on into part 2, you can expand vertex form, which is our f of x is equal to ax minus b squared plus q, and we can compare the resulting coefficients within standard form. And so standard form f of x is equal to ax squared plus bx plus c to see the relationship between the parameters of the two forms of a quadratic function. So basically what we're going to take a look at here is we're going to take a look at our vertex form equation, and we're going to expand it into standard form. So what I would like for you guys to do, to try out, is to see if you can take this vertex form equation and see if you can make it into standard form. So first thing we're going to have to do is square our term, and so that means it's like x minus p times x minus p. Then everything gets multiplied by a, and then after that we add q. So give it a try, pause the video, and come back when you're ready to go over it. Alright, so hopefully you've had a chance to kind of see this and maybe see how it works, or try it out anyway. So let's take a look and start off. And I'm going to show you the whole thing here all at once. We're going to go line by line and kind of explain each thing. So don't be too alarmed by what we see yet. We're going to slow this down. So let's take a look at our first one. Okay, and we'll just go through and kind of highlight a couple of important points here. So our first one, notice that we did x minus p and it's squared. So that's x minus p times x minus p. So my first two terms would be x squared and then minus 2xp plus p squared. Okay, so all we did in that first step is just expand that square term. Now, second, we took this a, and this a term is then going to multiply each term inside the bracket. So that's where we get our ax squared minus 2axp plus p squared. Now, after that, notice that we have an x squared term, we have an x term, and then we have a constant of ap squared plus q. So what can that tell us? Well, here's our standard form, right, straight across. So really what we can see here is that b is equal to negative 2ap. Okay, so basically we can match up what we have and see that our b right here matches up to this, negative 2ap, and our c term really matches up to all this, where our a term actually stays the same between the two of them. So we can see that b is equal to negative 2ap, or if I were to rearrange this for p, because you know p is the x value in our vertex, then I can see that p is equal to negative b over 2a, which is something that might seem familiar to you. So I can take standard form, plug in minus b over 2a, and that will tell me the p value, which is the x value in our vertex, which is also the axis of symmetry. Now we can also see that c is equal to ap squared plus q, okay, or I could rearrange this for q, and again remember q is our y value, which also tells me my max and my min, and this value is going to work out to be c minus ap squared. And so I now have two different equations, if you want to call them those, two different setups, I guess, that we can use to find p and q in vertex form right from standard form, minus b over 2a and c minus ap squared. Okay, those will tell me the vertex right off the bat. Now likewise, and maybe you've been taught this before, is that what you can do is you can just plug in your p value back into the equation, and that will also tell you the q value. That will tell you y at that point, so at the vertex, which is a pretty common method to use. So let's go through those and get a little bit of practice in here. So remember that you can determine the x-coordinate of the vertex. You can use the equation x is equal to p. And so in vertex form, then we have our equation. And just kind of remembering here that we have minus b over 2a as our way that we can calculate our y value, our x value. And so I've got this equation, y is equal to x squared minus 5x plus 6. Okay. And so what we're going to do is we're going to plug in minus b over 2a, which is really saying minus a minus 5 divided by 2 times 1, right? Because a in this case would be 1. So using those values, I can see here that if I have minus 5 minus times a minus is a positive, and so 5 over 2, or 2.5, becomes where my x-intercept is. Or sorry, my axis of symmetry. And then from there, once I know that, I can then plug this back in. So using this, we can now determine the vertex. And so we've got a couple of different ways that we can do this. So showing you that last slide one more time. Okay, we've got Q is equal to C minus AP squared, or I could plug in 2.5 back into my equation, or 5 over 2, and that will also tell me what my vertex point is at that point. So the x-coordinate of the vertex in this case, it says is, from our standard form, is minus b over 2a, which also makes our axis of symmetry. So determining the vertex, let's plug in 5 over 2 or 2.5 into our equation and start to go through and just kind of solve and see what you end up with for your y-intercept here. Okay, so we can either plug that back in, or like I said before, we can use this c minus ap squared, and that also gives us the same answer too. I kind of like the 2.5, it's a little bit easier, so give it a try and just come back when you're ready to go through. Alright, so just really quickly, 2.5 squared gives us 6.25. Okay, just kind of plugging this in. So really what we have here is 2.5 squared minus 5 times 2.5 plus 6. And so 2.5 times 2.5 is 6.25 minus, and then we have 5 times 2.5 is 12.5 plus 6. And so we can just kind of plug in our values here to see what we're going to get. So plus 6, and then plus 6.25. So it gives us a value for our vertex, okay, for right here, of 2.5 comma negative 0.25, okay, which is what y would equal here. So we can plug that back in to solve for our vertex point. Alright, so I've got 4 different examples that are here, and in each one is the same thing. So in each one of these, what we're going to do is we're going to go through and find the direction of the opening, the coordinates of the vertex, the maximum or minimum value, our axis of symmetry, our x and y intercepts, and then our domain and range. So for each one of these, I would like for you to pause the videos along the way, try them out, see how much you can come up with on your own, and then come back when you're kind of ready to go over the answer for them. So in these ones, we're going to see the graph, we're going to see the equation, and we just really need to make those characteristics. Okay, so pause the video, give it a try, see if you can label them, and come back when you're ready to go through. Alright, so for our graphlets here, well, we can see it. It's y is equal to x squared. It's our basic one. Our direction of our opening is upward. The coordinates of our vertex are right here. Looks like they're 0, 0. Does this thing have a max or a min value? It has a minimum value that everything has to be greater than. And we always have to also state where that minimum value is. So it has a minimum at y equals 0, which is actually always the y value from our vertex point. The equation of the axis of symmetry, what cuts it in half? Well, straight through here, looks like it's at x equals 0, which is always going to be our p-value, okay, or our x-coordinate of our vertex. X-intercepts and y-intercepts. In this case, this thing only actually has one root. It has one x-intercept, and that's at 0, 0. And in terms of its y-intercept, it also crosses the y-axis at 0. Now, domain and range have kind of a set format that we use. So our domain starts at that squiggly line. We define the variable that we're talking about. And then in this case, x can be any value. So it's really just x ER, x epsilon r. Just saying that x can be in the set of all real numbers. Now, y has some restrictions to it. Y has to, in this case, be greater than or equal to 0, such that y is also in that set of real numbers. Okay, so basically we're going to go through and just kind of practice a few of these out. Alright, so here's our next one. Again, pause the video, give it a try, and come back when you're ready to go through it. Alright, so in this case now, we have our opening, and we can see that this thing opens upward still. So opening would be upward. We can see its vertex point is right here, which really looks like it's 1, -1, but we can kind of verify that as well. Okay, this is what it looks like it is, but let's take a look at our equation here. So remember that my x-coordinate really I can find by doing minus b over 2a, and so really this is just equal to, here's our b value, minus 2 over 2 times 1, because our a value in our equation is 1, okay, which is right there. So x then is equal to 2 over 2, negative times a negative is a positive, and 2 times 1 is 2, which means that x is just equal to 1. So we know that we have our vertex value right at 1. Now if it's -1, I should be able to plug that back in, and how we do our function stuff is we always, instead of saying f of x is equal to, if I wanted to evaluate what the function is at 1, then f at 1 is 1 squared minus 2 times 1. I just plugged it back into the equation. And so then f at 1 is 1 minus 2, and f at 1 is -1. So I do have my vertex point right. So our next one after that is saying, and once we know that vertex, I've got 2 other main characteristics here that I can kind of look at and calculate. One of them being my roots, and the other one being the y-intercept. And so my y-intercept, remember, basically we're just taking a look and seeing what's the function when x is 0, right? We're evaluating it at 0. 0 squared minus 2 times 0, well, f at 0 is 0. So that actually helps me out quite a bit with my y-intercept right there. And I can see it on my graph that it looks like it crosses right here, which also looks like it's one of the roots. Looking at the max-min point of this, so for a max-min, this thing has a minimum, and it has a min at y equals -1. After that, I've got my axis of symmetry. So remember, my axis of symmetry cuts this perfectly in half, and the axis of symmetry in this case is at minus b over 2a, and so my axis of symmetry here is going to be x is equal to 1, which is also the x part of my vertex. The x-intercepts are next, and so for our x-intercepts, here I can take a look and see, because I can kind of look at my function here and see that this looks like it has a common factor. So f of x, and again it looks like it's 0 and 2, but we can kind of verify just to make sure here. If I were to factor an x out first, I'd have x minus 2 left over, and then I can see here that in order for this to be 0, then x has to equal 0, or x has to equal 2. And so our x-intercepts are going to be 0, 0, as well as 2, 0. Our y-intercept we knew from earlier because we plugged it in, but you can also see it from the graph. Looks like it's at 0, 0. And then after that we just have our domain and our range. So for our domain, remember we start with those squiggly brackets. We say what x is. For quadratic functions, x is almost always in the set of real numbers unless it's some real world situation that we have to have restrictions for. Our range in this case for y is going to be that y is greater than or equal to -1, such that y is in the set of real numbers. So that gives us all of our information for this graph that we really have up to this point. Alright, let's try with the next one. So again, pause the video, give it a try, see how much of the information you can come up with, and then come back when you're ready to go through. Alright, so for our next part, what are some things I can see right away here? Well, we have our opening. Again, hopefully you've had a chance to go through this. So I can see that this opens down. It looks like it has a vertex right here. It looks like it crosses the y-axis right here and has a couple of roots here and here. So those are kind of our important pieces of our graph that we can use to really draw this out. So minus b over 2a, remember, is going to tell us a little bit of information. So minus b over 2a, which is going to be minus b in this case is 2 and a is negative 1. So minus 2 over 2 times negative 1, that looks like that's going to be negative 2 over negative 2, which is going to be positive 1. And then if I plug 1 back into the function, then it looks like I've got negative 1 squared plus 2 times 1 plus 8. So the function at 1 is going to be negative 1 plus 2 plus 8, which is like saying 10 minus 1. And so it is just kind of like what we can see on the graph here. And I can see my vertex is actually just going to be 1 and 9, which is my next point. So my vertex is 1, 9. In my next part, I can see this thing has a max. Okay, so for the max min part, does it have a maximum or a minimum? It has a maximum, and that maximum is at y is equal to 9, right, straight across here. After that, I can see that its axis of symmetry is just the x value of my vertex, so x is equal to 1. We can see that the x-intercepts here, if I look like maybe we can factor this out some to kind of see what's there. So f of x is equal to, and then check to see if it factors. Again, it looks like minus 2 and 4. If I factor out that negative first, then I've got x squared minus 2x minus 8. And so then f of x is equal to negative x minus 4 x plus 2. And then I can see here that the graph does open down because my a value is negative, but also the zeros here are x equals 4 and x equals negative 2, which is just like what we were kind of thinking that we had. So x-intercept looks like it is negative 2, 0, and 4, 0. Now my y-intercept is next, and so y-intercept here crosses the y-axis at 8. That's just making x 0, so 0, 8. And domain for this thing is going to be x such that x is in the set of real numbers, and then the range is going to be less than, in this case, less than or equal to 9, such that y is in the set of real numbers. Alright, so again, going through and listing all of our points. Alright, one more to go through. Pause the video, give it a try, and come back when you're ready. Alright, so last one. Here we can see that we have our opening opens upward. We can see that this thing has in terms of a max or min, it has a minimum value, but we don't know what that is yet. So max, min, it has a min value, and the min value is at y is equal to something. It's going to be the y value of our vertex, which kind of speaking of that, I can then use the same stuff I've been using before now. Minus b over 2a is going to help me quickly find this. So minus a minus 12 over 2 times 2, which is really saying 12 over 4, which is going to give me 3. And then if I plug 3 back into my function, I'm going to have 2 times 3 squared minus 12 times 3 plus 25, which means my function is going to be 3 squared first. 9 times 2 is 18, minus 36 plus 25. And so my function here is going to work out to be 7. So that means that I have a minimum value at y is equal to 7. This thing then has a vertex that we just calculated, and its vertex here is going to be 3, 7. Okay, right there. It has an axis of symmetry of the x value of that vertex. Okay, so x is equal to 3. X-intercepts, there are none here. You can see that from the graph. So this thing actually doesn't cross the x-axis at all. It has a y-intercept of 0, 25, and I can see that right from the equation by making x 0. The domain is the same, XER, and then my range in this case, because I have a minimum value, that means that y is going to be greater than or equal to 7, such that y is in a set of real numbers. Alright, so that was going through a bunch of different scenarios where we can use standard form to make the characteristics. We're going to move on to our next section. We're not going to worry about our extra practice stuff. If you would certainly like to try them, you can, and you can just show me and I can help you go through any questions that you have. We're just not going to cover those in the video. So in our next section, we're going to carry on to some word problems. So let me know if you have any questions.